Hello students, good morning. My name is Dr. Mallikarjun, working in the Institute of Aeronautical Engineering in the Department of Information Technology. In the series of video lectures of the course Operating Systems, today we will discuss first come first serve scheduling with overheads, FCFS with overhead. How FCFS algorithm works with the overhead time is given. So FCFS algorithm we discussed in my previous lecture. So this video lecture I introduce the overhead with the first come first serve scheduling algorithm. Means what? FCFS. So FCFS means first come first serve. It is one of the simplest types of CPU scheduling algorithms. Processes are attend to the order in which they arrive in the ready queue. Much like customers lining up to the grocery store, how they are grocery to store will the customers are arrived one by one. So this is a store. Let me store. That person who is there in the first, they can get the chance. Once he completed, then second person enter into the grocery store. Once he also completed, then third person enter into the grocery store. So is the similar way the first come first serve scheduling works. Let me see the first come first serve scheduling is completely non-preemptive algorithm. Its meaning once a process starts running, it cannot be stopped until it voluntarily relinquishes the CPU. This is a completely non-preemptive scheduling algorithm. This CPU typically, when it terminates or performs the input-output operation, means that the process completed, then it gives the next process for the execution. This method schedules process in the order they arrive without considering priority or other factors. So we are not considering the priority here. So once the process comes, it is completely executing, then it gives chance to the next process for the execution. As per the first come first serve scheduling is completely non-preemptive scheduling. There are two scheduling process. One is preemptive and non-preemptive. So this is very important. Preemptive scheduling means once process submit to CPU, it can switch to the next process. That I am explaining in my previous lecture because of the time quantum or time slice. Then the process can be switched to give the next process for the execution. If time quantum is there, that much of time the process is executing. If time quantum is over, then the process gives the next process for the execution. It's mainly the process can be stopped by the interrupt. You give the next process, give the chance for the execution. This time quantum and time slice comes under the scheduling algorithms like round robin, shortest remaining time for scheduling algorithms. Okay, this non-preemptive is completely different. Once as a first come first serve scheduling algorithm is totally depend upon non-preemptive scheduling algorithm. A running process cannot be interrupted to the operating system. It's voluntarily submit to CPU until it's completed. The process hold the CPU till it get terminated or reaches a waiting state. A non-preemptive scheduling algorithm is completely first come first serve scheduling is a non-preemptive scheduling algorithm. Okay, how that first come first serve scheduling algorithm with the overhead we will discuss with the one exercise problem we worked out how this first come first serve scheduling algorithm works with the overhead. We will see. Okay, students. So this is the problem. How first come first serve algorithm works with the overhead. So the overhead we can represent with the delta. So delta is the overhead. It may be represented with the 1 unit of time. So if delta is represented with 1 unit of time, how this first come first serve scheduling works with the explanation with the I will show with the Gantt chart. So I draw the Gantt chart here. In this Gantt chart, at 0th interval of time, so which process will come? So is a overhead. Starting with the overhead, that overhead I shown as the delta. Once the delta is the overhead, means that up to 1 unit of time, no process can be executed. So overhead is the overhead process. Now time unit 1 as first come first serve, then give the chance to first process P1 enter into the Gantt chart and execute 3 units of time because its burst time is 3. So 3 plus 1, 4 units of time P1 is executed. So up to 4 units of time P1 is completed. So then again it go to the overhead. Overhead comes every time once process before it's entering, before it's leaving, then every time overhead is executing. So overhead, that's why it is first come first serve scheduling with overhead. That's why I represented overhead is 1 unit of time. So P1 is completed. Now overhead is started and executed at 1 unit of time. So then up to 5 units of time, up to 5 P1 is so overhead time is 1 unit of time. So 4 plus 1 5. So overhead is over. Then which process will come? Second process P2 will enter into CPU and execute 2 units of time. So it takes the 7 units of time up to P2 is executing. So again takes 1 unit of time is overhead delta comes it 8 unit of time up to is overhead takes place. Then P3 comes into the CPU and starts execute P3. So up to 1 unit of time, 9 units of time P3 starts executed and it completed. Then again delta is the overhead and execute 1 unit of time, that is 10. Now P4 enter into the CPU and execute 4 units of time, that is 14. So P4 is completed. Then again 1 unit of time is the overhead. Then up to 15 units of time it's there in the process for the execution is overhead time 15. So P4 is completed. P5 comes and takes for the execution P5. So P5 burst time is 5 units of time. It executes 5 units of time. P5 up to 20 units of time. P5 is completed for their execution. Next, overhead is the delta is the overhead comes and execute 1 unit of time. 21 unit of time up to delta is executed. So next, P6 comes and enter into the Gantt chart. It's a 2 units of time. P6. So 2 means 21 plus 2 up to 23 units of time. P6 is completed. Now all processes are completed with the overheads. So every process we observe P1 delta, P2 before and end delta, P3 before and end delta, P4 before and end delta, P5 before and end delta, P6 also there. So up to P6 all processes are completed. So P6 are completed, then overheads also completed. Then we calculated the completion time. So completion time you can see from the back to front where it be there in the completion time. So completion time P1 is completed at 4 units of time. That is the completed time for P1. P2 is completed at 7 units of time. So P2 is completed at 7 units of time. P3 is completed at 9 units of time. is the computed time for P3 is 9 units of time. P4 is computed at 14 units of time. So P4 is computed 14 units of time. P5 is computed at 20 units of time. Computed time for P5 is 20 units of time. P6 is computed at 23 units of time. P6 completion time is 26 units of time. Now we calculated the completion time. Then we calculated the turnaround time. So completion time minus arrival time is a turnaround time. So 4 minus 0 process P1 turnaround time is 4. 7 minus 1 6 is the turnaround time for process P2. P3 9 minus 2 7 is the turnaround time for P3. P4 is the completion time 14 and arrival time is 3. P4 turnaround time is 11. P5 completion time is 20, arrival time 4, that is 16 is the turnaround time for P5. 26 is the completion time for process P6, it arrived 5 minutes of time, P6 is the 21 units of time, process P6 is arrived, that time turnaround time. Then waiting time. So waiting time we calculated as the turnaround time minus burst time is a waiting time. So 4 minus 3 waiting time for process P1 is 1 is the waiting time. 6 minus 2 for process 2. So 6 minus 2, 4 is the waiting time for process P2. 7 minus 1 is the 6 units of time. Waiting time is 6 units of time for process P3. 11 minus 4, 11 minus 4, that is 7. 7 is the burst time for waiting time for process P4. 7. 16 minus 5, 11 is the waiting time for process P5. And 21 minus 5, 16. 16 is the waiting time for process P6. Then we calculated as the average waiting time. Similarly, that is average waiting time is 1 plus 4 plus 6 plus 7 plus 11 plus 6, 16 by total number of process 6. That is 16 plus 11, 7 and 27, 27 plus 7, 34, 34 plus 6, 40, 44, 45 by 6 is the average waiting time. So 7.5 is the average waiting time for this FCFS scheduling with overhead. So we calculated the average waiting time, the process scheduling with overhead. So overhead is the important point we discussed in the first come first serve scheduling. So overhead is calculated as the delta, that is 1 unit of time. Here we represented. So first come first serve is a basic CPU scheduling algorithm where processes are executed in the order they arrive in the ready queue. It's simple to implement, but it can lead to long waiting times for short process if a long process gets to ahead of the queue first. Mainly we represented here it is a overhead. In this context, typically refers to the time required for the context switching between process, that is a overhead. This overhead can impact overall the system performance. System performance is going to decrease by using the overhead. System takes a long time in the executing in the overhead. In the problem we seen, in the previous problem we seen the overhead we calculated here. Delta is the everywhere we calculated the overhead for the process. So that we represented as the overhead can impact the overall system performance. That overall system performance is going to decrease when overhead is increased. So that's a very important point. Overhead is increased, system performance is going to be decreased. That's we noticed here. So especially in the first come first serve scheduling comes a problem of the convoy effect that we discussed in the last video. That convoy effect is the disadvantage of the first come first serve scheduling algorithm. So, and also overhead also one of the problem in the first come first serve scheduling algorithm. So that's remaining scheduling algorithms are invented. Round robin scheduling algorithm is the best scheduling algorithm compared to all scheduling algorithms. That's what we discussed it so far. So that students, so we seen that we calculated up to now arrival time, burst time, completion time, waiting time, turnaround time, and also in this video lecture we seen the overhead extra for this video. Overhead is the time to respond for every process before and after in the first come first serve scheduling. So arrival time means the process enter into the ready queue. Burst time means the process need to execute on the CPU. Completion time means when a process finish its execution. Waiting time means process spends waiting in the ready queue. Turnaround time means the total time from arrival to completion. Then we've seen in this lecture as extra is overhead. Okay, students, this video lecture collected the information from the books of Abraham Silbert Scrapped, Peter B. Galvin, George Gang book in the title of Operating System Principles, Wiley Publishers, 8th edition, 2010. And also we referred the book William Stallings title Operating System Internals and Design Principles, Pearson Education Publisher, 6th edition, 2002. This video, first come first serve scheduling with overhead in detail. Okay, students, thank you. Thank you very much.
Like, share and subscribe. Hit the bell icon for more updates.